Welcome everybody. This is Professor Ma. This is the summary to the sections sign charts and inequalities. Given the formula f of x functions, and of course in previous sections we talked about solving for zero. Okay, and that of course the other question is when is f of x does equal to 0, which we sort into two parts. Once f of x positive, that is bigger than 0, then once f of x less than 0. Now, these questions help us in the future to do graphs to make a one-dimensional picture, the sign chart, which is a one-dimensional graph that we are going to make. We're going to take that and stretch in a two-dimensional graph. So therefore, it's very important. This is one of the most important concepts we're going to study. This change from a formula to a sign chart to pictures. Okay, and we're going to do this for polynomials, factorable polynomials. So, okay, and we're going to use the factorable polynomial to determine the outcome of the sign. So here is a problem that to remind you how do we determine the sign of the outcome. Very simple. We use the factor form, but use this form because when we plug in the x, then all we have to do is track the sign, and if we plug in -3/2, it's going to be minus times minus plus, and it's -1/2. Then we're going to get a minus, because the two parentheses is going to be negative and positive. In other words, we can determine the sign easier than plugging the number, find out what the output. If it's factor, we can multiply the sign of each factors. And this works for fraction formula too. If it's factor, and I can plug in -3/2, and then I will get the corresponding minus sign in the parentheses, minus times a minus on top, and the minus times the positive on the bottom, and one with a negative numbers. And for -1/2, one with a positive results. Okay, and to differentiate which numbers, which x makes the formula positive, which x makes it negative, we express the results on a line, on the real line. In other words, the one-dimensional graph of the formula. Okay, for example, here is the sign chart of f of x equal to x minus 1. At x equal to 0, sorry, for f equal to 0, and you solve x equal to 1. So therefore, at 1, and that single point right now on the pictures is where the sign of the output is neither positive nor negative. It's 0, it's neutral. Okay, if I plug in numbers to the right-hand side, I will get positive. If I plug in numbers from the left-hand side of 0, I will get negative result. Okay, for example, if I plug in here x equal to 3, and take 3, plug it in, 3 minus 1 is 2, and that's a positive number. So that's why and this side is a positive side. All the numbers on that side, you can check, you will get positive result. And this is the chart we want to develop for each formula. Okay. And here's the steps written out, but here, let me give you another example how we do this. Okay, here's a second degree one. Okay, so we want to construct a sign chart for these second degree formulas. And so the sequence of things we have to do is first find out where it is 0. That is not positive nor negative. Factor, find out what is 0. Now from here on, we're going to change it into picture mode. Okay, we're going to start drawing doodle with a little line, and we're going to start drawing little doodles on the line. And the 1, -1, and 4 are neutral point. The output is 0. So the pluses and minus are distributed in all these other points will result when we plug in the formula, you will get say positive number or negative number, not zero. And how do we find out? One way to do this, which we will simplify later, is take a point in each segment and sample it and check it. So for example, test -2 in the left-hand segment, if I put it in there, I will get plus output, positive output. Therefore, I can identify that portion, all the outputs will be positive. Then similarly, if I check 0, I will find out the middle portion will produce output that are negative. And if I'm to the right-hand side, choose a 5 to test what the output is, and I find out it's positive again. So in other words, this is the sign chart of, that's it. This is a sign chart of x squared minus 2x plus minus 4. Okay, of course, these test points, when I say this is a sign chart, these are just test points, and they're not really, whoops, I want to do this. But all I want to do is just say these points, these test points, they're not part of the picture. So the picture for the sign chart, actually, this is it. Okay, and I put those test points in the PowerPoint just to show you the points I choose to test the sign. Okay. Now, there's an easy way to do this. In particular, to the kind of formula we want to study. The kind of formula we want to study are factorable polynomials. They can be factored into linear terms, x minus something, x minus something, x minus something. Of course, there might be repetitions of the factor. So the power is the repetitions. So these are type of formulas we're going to study. And in particular, if the formulas factor in these fashions, then I can eyeball the roots, the R1, R2, up to RK are the roots. And the power, this power, we call the order of the roots, the order or the power of the root, okay? The power of the root. That is how many times did it show up. So, for example, if I were to factor this, factor it all the way down, this is what it factors into. From here, I can read off the roots. They are 0 from this. And for x plus 2, the roots is x minus 2. And for x minus 2, the root is x equal to positive 2. So I get these 3 roots. The x shows up 3 times. The power for the x is 3. So the order of 0 is 3. It's that power is the order. So 0 has order 3. The minus 2 is order 2. And the positive 2 has order 2. Now, what's important actually is whether the order is even numbers or odd numbers. And I will call, in this case, the 0 is on odd order roots because it shows up 3 times. The 2 and minus 2 shows up twice, so they are even order roots. Okay. So here's the easy way. So summarize it, it says you can discard the even order roots. They don't matter in the sign chart. The only roots that matters are the odd order roots. And when the sign chart produced under the odd order roots, basically when you cross an odd order roots, the sign will change. And across even, it doesn't change, meaning you can ignore it. So here we go. Here are the 3 roots. And minus 3, okay, 0 and 3 are odd order. 0 came from here, 3 came from here. Respectively, the order or the power came from 1 and 3. So those are odd powers. So therefore, 0, 3 are odd order. But the -3 has order 2, power 2. So that's an even order. So there's a two times. Okay. So now I draw it. And then the way to compute the sign chart is, remember the even order one, it really doesn't matter. You can pretend that's not it. Okay. So to find out what the signs are for the other sections, I check one number. For example, in this case, I don't know what I did on the PowerPoint, but right now I say let's check x equal to 10, or even some bigger 100, something really easy to identify. If I'm putting 100 in there, everything is positive. So it will be positive on this side. Okay. Example, check. Okay. And I get positive. And when you cross odd order roots on the other side, it will switch sign. When you cross odd order root 0, well, it will switch back to plus again. And when you get to -3, even, it just ignores it. It pretends not. So this is the sign chart for this particular. Okay. Inequality or inequality problem can be phrased into sign chart problem. If I want to look at the formula study, say solve f of x bigger than g of x, one formula bigger than the other. In mathematics, we transform this problem into either f minus g bigger than 0 or 0 bigger than g minus I. Either one. We change the problem into A or B, whichever is convenient to factor, and from here we do the sign chart. Okay. To solve the problem, the sign chart of what? The sign chart of the difference of the two formulas, instead of solving the original formula, f of x bigger than g of x. So we change into a sign chart problem. How do we do sign chart? Well, here's a fractional problems, same way with factors. Okay, list the roots and list the orders, and these are the roots. Okay, and notice that at x equal to 1, the formula is undefined. So at this point, I should really put a triangle indicating this is something different from the roots. This actually was undefined. Okay. And then I can use the sign chart for this formula, which is, if you check, I'm going to skip this, it's going to be minus, plus, plus, plus. Mm-hmm. And in particular, after we get a sign chart of this problem, then we go back to the inequalities. Aha, less than 0, this means negative. So the problem asks for where are the negative sections. And that will be the solutions for this problem. We only work for x bigger than 2. Absolute values. We had absolute value from last sections, and so we remind you again, the absolute value of between x and y is x minus y, means the distance between x and y. In particular, x minus 0, or x is the distance between x and 0. Okay, so x to 0 distance. So if I have this inequality, what it's saying is, well, draw the solution for the absolute value x less than 7. So this means you want the distance from x to 0 smaller than 7. So this is the picture for it. Okay. And in general, this is translating to the distance between x and y. So this phrase translates into the distance between x and y is smaller than c. Hence, if we draw these, c is 2. So y is 2. Y is 2 and c is 3. So in particular, 2 is the center over here. And I want the x that's within 3 units to 2. So that's the translations of this inequality. And in calculus in general, you will see this absolute value inequality often. This means a little bit of neighborhood around x equal to 8. So this is just in an abstract settings, and some point A over here, I want to talk about a little neighborhood of radius, some unknown number, and a lot of time we call it epsilon, we call it little e. So this is a plus epsilon, and the other left hand side is a minus epsilon. And this stretch of number, that we call this the epsilon neighborhood of A. Okay. And this is written in the absolute value notations, looking like this. And so this is that picture. It's very important. When we mention inequality like that, we are thinking about a little neighborhood around it. Okay, in some pictures. And this is points. This is given concrete numbers, and this will be the neighborhood around that. Okay, and this is these sections, and good day, and see you next time. Bye bye.